Hello everybody, welcome back to Cement Manufacturing Practice Series, episode number 7 on Chemical Industries Engineers channel. After chemical compositions were monitored by blending step, we should monitor the rate of the feed. For this reason, there are two basic systems used, gravimetric system and volumetric system. Gravimetric system uses the weight as a measurement unit, where the load cell measures the weight of the feed and then transports the feed over the belt in boxes. The rate measured by using the weight of the feed and the speed of the belt. The advantage of this system, it doesn't need calibration, sensitive to density variation, easy to control the feed rate, sensitive to material supply interruption. Where the disadvantage, more expensive than volumetric system and not sensitive to materials building up. Where volumetric system uses the volume as a measurement unit. Its advantage, sensitive to materials building up and less expensive than gravimetric system. Where the disadvantage, regular calibration are needed, not sensitive to density variation, and not sensitive to material supply interruption. After controlling the amount of the feed, one of the following systems is used to transfer the feed to the kiln, built with boxes or airlift system. And now, let we talk about the preheater. It's developed in order to raise the temperature of the raw meal to calcination temperature before enter to the kiln. Series of cyclones used, where the hot gases come from the kiln and transfer the heat to the raw meal. The feed and gases separated by cyclonic action, where the feed go to the next cyclone and the gas go to the previous one. The feed enters the preheater stage at about 60 degrees Celsius and enters the kiln at about 850 degrees Celsius, where the gases leave at about 300 degrees Celsius in four-stage preheater system. The pressure drop is important in the preheaters because more pressure drop in the cyclones lead to lower fuel efficiency, and the increase of the number of cyclones will increase the pressure drop. So, new cyclones of low pressure drop have been developed. In new design, 6-stage preheater have pressure drop less than or equal to 4-stage preheater of old design. And about the power consumption, in new designs, the power consumption of the fan reduced by about 50%, and the fuel consumption reduced by about 25 to 50 kilocalorie per kilogram. And it's noticed that using of bucket elevator is better than using the airlift system in order to reduce the power consumption. To design the cyclones, we have many parameters, like the diameter of the discharge outlet between the cylinder and the cone, inlet area of the feed, the slope of the cone, the speed of the air, and outlet area of the gas. All these dimensions vary depending on the manufacturer, but in general, the most used parameters with all manufacturers are the following. Regarding the entrance of the duct, its width to height ratio about 1 to 2 ratio. The preferred slope of cyclones with x-axis is 60 degree. The velocity of the air about 18 meters per second at the inlet of the gas and about 15 meters per second at the outlet. Single stream system used in plant requires up to 5,000 ton per a day as a feeding, while double stream system used for plant requires more feeding. In some plants which use double kilns for calcining and sintering, we will get two streams. The first is from the calciner, and the second is from the kiln. The stream of the calciner is larger than the stream of the kiln. So, in this case, we can get two streams, or we can combine two streams in one stream. In order to reduce the heat loss by radiation, for example, the cyclones are isolated by bricks or blocks. And we have a special design for cyclones. It's called horizontal cyclone. It's developed to reduce the height of the preheater tower, and it's usually used in intermediate stages. I hope this video is useful, and if you work as a chemical engineer in cement factory and interested to share your knowledge and experience with other engineers, please feel free to contact me at any time at my LinkedIn account. And don't forget to like, subscribe, and share the video. Thank you.